Welcome, everyone. It's my great pleasure to introduce Professor Paul Shiels for today's HNRCA seminar. He is the professor of geroscience in the School of Molecular Biosciences at the University of Glasgow and founder of the Glasgow Geroscience Group and chair of the Scientific Advisory Board of the British Society for Research on Aging. He's published over 200 papers and has numerous patents. One of the things I find particularly exciting about Professor Shiels' research is the way in which he not only links extrinsic nutritional factors to aging-related health, but also interrogates the mechanisms by which those two upstream and downstream factors are linked, whether that be through somatic mutations or changes in the epigenome, or his current focus on the microbiome. I would also note that Professor Shiels' work considers health and aging not only from the perspective of individuals and communities and cities, but even at the level of planetary health. He is truly a broad thinker. We're very lucky to have him with us today. And just a reminder that if you have any questions, please put them in the Q&A and we'll go through them after the seminar. So thank you for joining us today, Professor Shiels.
Well, thank you very much. I'm delighted to speak to you. It's a new audience for me. Today, I will take you on a ramble through some of my work in the city of Glasgow over the past 15, 20 years and tell you a little about where we're going. So I'm going to start with a classical perspective. And this is Hippocrates of Kos, who a lot of clinicians take an oath to. And he's often famous for saying, "Let food be thy medicine." It's actually a misquote. What he did say, though, were that there are two things, science and opinion. The former begets knowledge, the latter ignorance. And that, I think, is really pertinent to a lot of research on aging today, as you'll see in a moment. Now, I think I've got myself, yeah. So today there are more people alive in the world age over 60 than at any time in history. So for once, humankind is actually doing something good. And that demographic of the aged is growing. And unfortunately, while we can keep people alive longer, we cannot keep them in good health to the same extent. So there's a gap between lifespan and health span. So trying to close that gap is important. And in that context, I'm going to go classical again and mention Galen of Pergamon. He was another Greco-Roman who said it is better to treat the patient with food than with medicine. The art of healing comes from nature, not from the physician. And as someone who started life as a hardcore molecular biologist, this has often been difficult for me to come to terms with. But as I've got older and more experienced, I am fully in agreement with this. So today, that growing demographic of the aged is really happening most prevalently in the global south. In the global north, we already have a population that is aged. And in the global south, you have countries that are least well equipped, both logistically and financially, to deal with the problems of an aging population with a gap in health span. And the problems that they will face will all be amplified by social deprivation. And what I mean by that really is a lack of opportunity. It is not simply financial. But when you think about the economics of this, the numbers people speak of are staggering. So the economic impact of socioeconomic inequalities in health in Europe has been estimated to be around 1,000 billion euros per year. So a European billion is 1,000 millions. It's 9.5% of the GDP within the European Union. and 20% of the costs of all healthcare systems in the EU. It's staggering. McKinsey has estimated for the US alone, just having a 1-year increase in healthy life expectancy, so that's health span, not lifespan, would generate around $6.2 trillion in GDP uplift. Again, an astronomical sum. And an increase in life expectancy by a single year would be worth 38 trillion to the US economy and 367 trillion over a decade. Staggering sums. I can hardly get my head around those. These figures really have created an environment akin to Mandeville's travels. So Mandeville was a Yorkshire knight in the 14th century who claimed that he had travelled to Tartary in the Far East, and he came back with fanciful tales of meeting scoliopods. That's men with one leg who would lie in the desert sun shaded by a single large foot. He had tales of Cyclopean Amazonian women, men with faces in their chest, and people with the heads of dogs. This was a medieval bestseller, but it is akin to a lot of what is happening in the area of research on aging, because there is some outstanding fundamental science. We now realize that aging is malleable, but there is a lot of overpromise and overhype with what we can actually do. And, you know, a quick browse online and you can find lots of this: anti-aging pills, anti-age biotics, rejuvenate yourself in only 60 minutes. It's all very fanciful. We can potentially reverse cellular aging. So at the level of a cell is one thing, but moving from a tissue to an organ to a person remains science fiction. What we can do is slow down the rate at which we age and therefore potentially improve our years of healthy living. In the real world, as we get older, what we see is the emergence of a diseasome of aging. So these are all distinct clinical modalities. Typically, they're treated independently. And these will include things such as neurodegenerative diseases, cancer, chronic kidney disease, which is a growing problem, osteoporosis, diabetes. So distinct clinical entities, but they all share a common underpinning component of a dysregulated aging process that precedes their development. The common features, all of which are affected by a change in environment, include diminished stress defenses, typically regulated by a master regulator of cytoprotection called NRF2, a loss of diversity in gut microbes, a growing inflammatory burden, and a loss of physiological resilience leading to frailty. I study this in the city of Glasgow. This is where we are. Hopefully you can see the pointer. Glasgow on the west coast of Scotland was once the second city of the British Empire. Many of you will be familiar with it, probably because the campus looks like Hogwarts and Harry Potter. It's a very beautiful place. The city is very green. The name means in Gaelic, the Gaelic language of the west of Scotland, and also in Irish, green hollow. It is a very green city, though it's not reflected on my pictures here. Unfortunately, health and life expectancy within the city has been problematic over the past 50 to 70 years. Scotland is the sick man of Europe, and Glasgow is the sick man of Scotland. And if you look at the chart on the right-hand side here, this red dot on the left of the column is Scotland in terms of deaths per 100,000 in Europe. It just sits below Albania, and it's a lot worse off than other European countries. If you break down areas in Scotland into council areas, then you can see that the picture is heavily skewed by the east end of the city of Glasgow, where there is a very steep socio-economic gradient, related to ill health. And within the city, we have both the best life expectancy on average for a male at birth and the worst life expectancy on average for a male at birth in the Western world, all within a 12-kilometer radius. At one end, life expectancy is in the high 80s, and at the other end, for a male, on average, it is 54 years, which is a disgrace in any developed country. So to understand why this is occurring, we need to understand why people living in deprivation in the city, in areas outlined here, have earlier onset of diseases of aging. And to do that, we have to understand at a fundamental level how we age. Unfortunately, aging is highly individual. I think it's reminiscent of the start of Anna Karenina, where Tolstoy says, all happy families are alike, but each unhappy family is unhappy in its own way. Each of us ages like an unhappy family. It's highly individual. We can hallmark features of how we age into those that are common across taxa. So common to flies, to worms, to yeast, to mice, and to humans. And these are things like, increasing genomic instability, telomere attrition, epigenetic dysregulation and loss of proteostasis, an accumulation of senescent cells, mitochondrial dysfunction, and a loss of nutrient sensing. These features become targets for intervention so that we can slow down or preempt how we age. And interestingly, it's been calculated that if you could cure both cancer and heart disease, you would only add no more than 2 to 3 years of healthy life expectancy to a hypothetical 50-year-old, whereas slowing the aging process could add an extra 25 years of healthy life because of the amount of wear and tear you'd have had to accumulate in the first place to get a disease. From my perspective, I'm going to use a very crude analogy. If you think of your body like a car, our medicine and our molecular and cellular biology means that if bits go wrong, we can fix it pretty well and keep the car on the road for longer. What we cannot fix is this, putting the car in the wrong place at the wrong time, the wrong environment, and it gets trashed. This is the impact of a bad exposome. Now, the exposome comprises the totality of human environmental exposures. That's both biotic and abiotic exposures, preconception to death, and I'll talk about this in a moment. And in essence, it's a framework for allowing us to understand how things in our external environment, such as air quality, exposure to pollutants, interacts with our internal biology, dysregulating it and predisposing to dysfunction and disease. And if you look at the great debate between nature versus nurture, then the impact of the environment is exceptionally strong. And this recent paper from Austin Argentieri and colleagues has indicated that exposome factors are driving around 80% of age-related health outcomes. As someone who started off as I said, a hardcore molecular biologist, I find this quite staggering, but I am in agreement with it. This, of course, is not the only consideration here. We have to consider biopsychosocial effects because aging is a process occurring all across the life course. And those biopsychosocial effects are exceptionally important. So this would comprise how you were raised by your parents. Was that a nurturing relationship or was it one that's abusive? Were your family supportive or were they competitive or abusive? Did you have a good, friendship network? Did you have access to good schooling, good recreational facilities, good nutrition? What type of house and neighborhood did you live in? Was it safe, secure, dry, warm? Or was it, did you live in a threatening neighborhood? And again, another interesting one, those that live the longest and healthiest lives tend to be spiritual. So was your community spiritual? This plays into cortisol-mediated stress responses that have a big impact on how you age and how long you live. Importantly, the exposome can count for approximately 50% of all deaths globally annually. And that's due just to 3 simple exposome factors: air pollution, tobacco smoke, and of course, diet. So my slides are not moving. They will in a moment. Here we go. Okay, so understanding how all those features knit together to impact our age-related health requires a lot of data. And at the moment, most exposome research draws on large-scale databases and surveys, and we need more functional exposomic data. And technological advances, and particularly the use of AI and portable devices, coupled with an ability to understand our genomes, transcriptomes, proteomes, metabolomes, over time will give us an insight into how our geophysical environment, our social environment, our nutritional environment, and our physiology all interplay. So the Shiels exposome is interesting because I worry about this, because traditionally we have thought that our health trajectory is determined in part by what was happening when our mum was in our grandmother's womb, and a bit of us was an egg in our developing mother. So our grandmother's exposome, her lifestyle, her geophysical environment, her socioeconomic position, her educational status even, impacts on how our mums develop and then us, and in turn, our mum's lifestyle, environment, her socioeconomic status, her level of psychosocial stress would impact on us. And if I look at my own, then my grandmother grew up during the Irish Rebellion, my mom during the war with the British between the 60s and 70s of the last century, and my own, of course, in the 1970s and 80s. And then you see that the effects on aging may take up to 6 decades after exposure to emerge. And I like, to berate my mum and my grandmother for their lifestyle and their environments. And then I discover that, of course, grandparents and dads do not escape this, that their sperm quality is also affected by their diet, and that will affect my health. Now, I'm currently the oldest living male in my family. Most of my dad's family died in their 50s. I'm now 64. I'm in Sniper's Alley. If I can make it through the next couple of years in decent health, I have a good chance of living a lot longer. But there's a blind spot for us in that what has happened in preceding generations does impact our own trajectory of health, coupled not just with our contemporaneous exposome, but those historical exposomes. And that is becoming more worrying in the context of planetary health. And I've entitled this slide with a little bit of Scottish Gaelic. It says, Ligan in Yeri Asser Suwain. A crisis is occurring and we are asleep, because we know that those historical exposomes can lead to bad health. But what we haven't really appreciated is that they are dysregulating our aging process as well. And a lot of the materials that we need to slow down that process and give us more years of good health are being lost to us as our planetary health declines. We are just another animal species living on the planet. We're not making a very good job of it in terms of how we have treated the biosphere that we live in. And we are on a worrying, it's almost like a death spiral, in that on our current trajectory, each new generation is likely to age faster as the health of the planet declines. So we really have to do something about this. How can we tackle this? Well, what I would like to do, as with many others who work in geroscience, is to bolt the stable door before the horse is gone and try to make our cells physiologically more robust and resilient in the face of declining planetary health. Myself and colleagues have been using the kidney to model this, using chronic kidney disease as a disease of accelerated aging and kidney transplants as a way of looking at normative healthy tissue whose function we can track longitudinally to work out how, when, why, and where we can intervene to improve health, with the view to taking those that have got a poorer trajectory of aging, as shown in the red here, and make them physiologically more robust and physically more capable, like those that are undergoing the black trajectory of aging where they do better. And at the same time, we need to bear in mind that what's good for us when we're young is not necessarily good for us when we're old. So this is the concept of antagonistic pleiotropy. And ideally, what we want to do is compress the period of morbidity at the end of our life, so those last 10 to 15 years when we typically get sick, and therefore increase our years of healthy living or our health span. So we need to achieve that by targeting the upstream effects of aging before the diseasome of aging appears and before our death is managed using geriatric medicine. So this is Glasgow, which is the model city for us to attempt to do this. And this is the underground system within the city. And if you move from the west of the city through to the east, at each stop, you are losing about 2 years in life expectancy. It's frightening. And this is just a subsection of that 12-kilometer radius that I mentioned earlier. If we look at the city, the specific features that are influencing aging and health in the general population are socioeconomic position, diet critically. We have differences in epigenetics. We see differences in phosphate toxicity associated with diet. We see poorer renal function, and we see microbial dysbiosis among the deprived that age faster. Typically, what we observe is that biopsychosocial effects also have a key part to play in how people age in the general population in the city, not in clinical cohorts. Inter-individual variation in biological age only explains about 10% of the variation in inflammatory burden. Now, typically, senescent or old cells secrete pro-inflammatory cytokines, and there's a very strong correlation between the number of senescent cells and inflammatory burden in laboratory and clinical studies. But in the general population, this takes a kicking. The key message that my research has shown over in recent years is that in a setting of deprivation, diet is a critical modulator of health because the deprived tend to eat red meat very frequently, and they do not eat sufficient levels of fruit and vegetables. So if we go back to Hippocrates and all diseases begin in the gut, or as this French chap, Jean-Antoine Brillat-Savarin said, give me, tell me what you eat, and I tell you who you are, essentially. You are what you eat. For this audience, it's a no-brainer. You already know that diet is a critical exposome factor. It accounts for about 22% of global deaths annually. And it's the single strongest lever to optimize human health, according to the Lancet Commission. The problem with here and elsewhere is that many humans, especially guys, think they're obligate carnivores. We are omnivores descended from frugivorous ancestors. And if we look at obligate carnivores like lions or tigers or leopards, and we look at their health related to what they eat, then taking that biomimetic approach, we see that these animals suffer phosphate toxicity. Almost 90% of them will die of kidney disease. This also includes domestic cats, pet cats. 50% of them will have colorectal tumors, and all of them will have an elevated inflammatory burden. Now, the phosphate toxicity is important because less phosphate in the circulation correlates with a longer lifespan in mammals. And this is just a chart illustrating this. Human centenarians have low levels of serum phosphate. Those with Hutchinson-Gilchrist progeria that live on average around 15 years have higher levels. And the mechanistic basis of this is understood, because if you cannot clear the excess phosphate as calcium phosphate from your system quickly enough, you tend to have adverse consequences for cellular health, because you get mitochondrial dysfunction, and then subsequently at a tissue and organ level, poorer function. So in Glasgow, what we've found is those that eat red meat over frequently and don't eat fruit and veg die younger. We find that they have renal dysfunction, and this is in the general population, so it's not clinically diagnosed, but many of those that are deprived have renal function equivalent to mild to moderate chronic kidney disease, stage 2 to 3. They also have more colorectal cancer, just like the big cats. So humans are just another species. A solution here, of course, would be to eat more plant protein and less red meat coming from domestic ruminants, therefore reducing the lower total cancer-related and cardiovascular-related deaths. Another knock-on effect of this is that if you eat red meat too frequently, then bugs in your gut can process the carnitine to generate trimethylamine. It's highly inflammatory. This is processed in our livers to generate trimethylamine oxide, which is even more inflammatory and a major contributor to not just renal dysfunction, but also to cardiovascular disease and to rheumatoid arthritis. So this is a real player that we cannot make ourselves, and it's made by the bugs in our gut as a consequence of having a diet that contains too much meat, red meat from domestic ruminants. And if we look at this Glasgow population again, where they show accelerated aging, increased phosphate toxicity, a greater inflammatory burden, an imbalanced diet, and poor renal function, we can see that carnitine being processed through the choline in this biochemical pathway can either generate trimethylamine that's processed as TMAO in our liver, or on another branch of the same pathway, betaine. And betaine is a key methyl donor needed to maintain placement of methylation groups on DNA and therefore your epigenetic landscape. We can make betaine endogenously within our mitochondria. But as we get older, our mitochondria become dysfunctional and they cannot make enough of it. And therefore, we can supplement what we lose through the activity of the microbes in our gut or via our diet. And what we observe in Glasgow is that those at lower socioeconomic status that show accelerated aging have less methylation on their DNA. And we find out that this is due to having too many unfriendly gut bacteria and unfriendly oral bacteria in particular. What we observe principally is that oral pathobionts linked to gum disease, to endocarditis, to neurodegenerative diseases, and to kidney disease, considering that we have a general population where they're deprived of poor renal function. This is worrying, and this is associated with an imbalanced diet. Among the affluent that age better, we observed more prevalence of a number of different types of bacteria that are associated with promoting good health. And in particular, these bacteria can process phenolic acids that we derive from eating fruit and vegetables to generate alkyl catechol that can activate NRF2, this master regulator of our cytoprotective responses. Unsurprisingly, a Western diet does not support the growth of such microbes particularly well. They are much better supported by traditional diets where food is preserved through thick pickling and fermentation, which is also a feature common to many of the blue zone regions where people live longer, healthier lives. And in Glasgow, interestingly, we see of these health promoting bacteria, lactobacillus, some forms but not all forms of Lactospiraceae, Pantoea, and Cocuria that can produce NRF2 activators. And many have the capacity to modulate the production of betaine and betaine precursors to affect the methylome of aging. Like NRF2 is really important in that we know its expression diminishes with age. It's also diminished through psychosocial stress, a Western diet, smoking, uremic stress. But it is promoted via exercise, through enhanced mitochondrial function, and by a range of differing phytochemicals that we know are xenotherapeutics, and it can help slow down aging and give us a better health span. And these include things like kimchi, rosemary, curcumin, flavonoids, and coffee. And many of them work as well or better than existing pharmacological agents. And this is just an example of perhaps the weakest of all these, which is sulforaphane from broccoli sprouts. And here you can see mice. These are sisters. They're all the same age. Those on the right-hand side have been given a sulforaphane diet. Those on the left with the scabbier coats looking more frail have been given a controlled diet. This is a potentially very safe and effective way to improve health span. So can we modulate this exposome of aging? I believe so. I believe we can do it at a number of different levels through modulating our geophysical environment to make it more biophilic and health promoting, modulating our social environment because being social in old age is critical to good health. And for this audience, I believe modulating the foodome is key, either to directly activate NRF2 and thus enhance our cytoprotective responses, or indirectly via modulating our microbiome. And interestingly, colleagues in Glasgow, among others, have shown that life expectancy could be increased by up to 10 years in the UK simply by shifting towards a healthier diet. Now, how to do that? I like taking the biomimetic approach again, because as I've mentioned, there's that biochemical pathway where on one branch you can produce the pro-inflammatory TMA, or on another branch, the salutogenic betaine. Humans and big cats tend to go towards TMA, but bears that hibernate have a natural switch, and they can switch to making more betaine simply through diet. If you prevent the bears doing this prior to hibernation, which is when they need it, then problems occur. And we're using the Asiatic black bear as a model for this, because in the East, black bears are caged, they're fed a human diet, they're often deprived of sleep in the course of extracting bile for Chinese medicine. They end up looking like this. These animals show an increased inflammatory burden, they're hypertensive, they're sarcopenic, they suffer from retinopathy, they suffer from chronic kidney disease, cardiovascular disease, arthritis, and microbial dysbiosis, all of which we see in deprived humans. It's a very, very unfortunate state of affairs for the bear. These can be rescued, they can be rehabilitated, and their rehabilitation provides lessons for how we can approach modulating our own exposome of aging. In the wild, European brown bears, unlike their American cousins, they have access to lots of salmon. They eat around 250,000 berries per day in peak season as they fatten up for hibernation. Those berries and the polyphenols they contain drive changes in the bear's microbiome, that have very, very powerful metabolic effects engendered by microbial metabolites. The polyphenols, typically anthocyanins, and also one that's well known in the field of research and aging, which is resveratrol, tend to give the berries the birds eat, the very bright colors. They have also been used in clinical medicine in small clinical studies to good effect. So there is precedence for taking what we observe happening in ursine biology to humans. And what we've observed is that if you do a fecal microbiome transplant from a bird that's getting ready to hibernate and give it to a mouse, and here we have a picture of two sisters, one that's had the transplant and one that's had the bear poop, then you can see within 2 weeks what that transfer does. It makes the mouse fat, torpid, and preparing it for hibernation. So that's solely driven by microbial metabolites. So modulating the microbiome is a very, very powerful lever for altering mammalian metabolism. In the clinical studies, people have used boysenberry polyphenols, blueberries, anthocyanin intake, and bilberries, that's European blueberries, to good effect, generally in metabolic studies in cardiorenal medicine. We are trying to do this in the context of chronic kidney disease because that's a disease we understand well as a disease of accelerated aging. And within it, it's got the biggest disconnect between chronological and biological age if you look across all the different organ systems in the body. At onset, it's about 5 years difference. When you need a transplant, you've got end-stage renal disease, and there the prospects are grim. 50% survival at 3 years in dialysis, 10% at 10 years. It's like having a metastatic cancer. As the kidneys fail, uremic toxins accumulate, and most actually of these toxins are microbial in origin. And the best solution is to transplant. That restores a more normative physiology and gives a better quality of life for more than 20 years in the best cases. If you look at what having a transplant does to the microbiome, it improves the situation because when you have chronic kidney disease and your condition is deteriorating and you're showing accelerated aging, then your microbiome has more and more bugs that make TMA, so you become more inflamed. That situation changes following the transplant as your physiology improves and gut leak stops, and you see an increase in salutogenic bacteria. The situation never becomes normal. You're on immunosuppression, but it improves their lot. And if you look back to where betaine is within one carbon metabolism, we see a very significant effect here because one microbial metabolite in this study can explain up to 25% of the inflammatory burden. So that's TMA, just one of a number of microbial-derived uremic toxins. So these metabolites are key to shaping that uremic microbiome, and that microbiome is malleable with respect to its composition. One of the ways we have tried to do that is to use resistant starch cookies, and we've been doing this in collaboration with Denise Mafra and Fluminense in Brazil. And here, what we're trying to do by feeding the resistant starch cookies just for a month to patients on hemodialysis is to reduce inflammatory burden by enabling the growth of bugs that can make short-chain fatty acids. So these are anti-inflammatory. And we're looking at changes in renal function and microbial composition. And to cut a long story short from these studies, what we observe is that we can increase the numbers of the salutogenic gut bacteria able to produce anti-inflammatory, so short-chain fatty acids, and to activate NRF2. We're also trying to do this with complex polyphenolic mixes. And to that end, we've been conducting some studies using Brazilian green propolis. Propolis is a component of beeswax. It's not a standard formulation, and it really depends on the diversity of sources that the bees feed on to give you an indication of the level of variation you can achieve in propolis. But in general, it's an anti-inflammatory. Its metabolites can be used to activate NRF2 and therefore enhance the renal function of those on dialysis. Interestingly, other groups have been thinking about doing fecal microbiota transfer to reverse the effects of aging. And this has been reported in mice. I'm still very skeptical of this. And that I was relieved to see, and also pleasantly surprised to see very recently, that in other studies, diet outperforms microbial transplants to drive the recovery of a normative microbiome in mice subjected to insult. So for me, I think the exposome is a very powerful mediator of aging and health. I think using food to manipulate biology as a component of the exposome is good. I like a natural sciences-based approach to do this because I think they work. I think known pharmacological models and exposome pharmacology may help. No, we can improve health span and make our cells physiologically more robust in the face of declining planetary health using this type of approach. So back to Hippocrates. If we could give every individual the right amount of nourishment and exercise, not too little and not too much, we would have found the safest way to health. And here we are, almost 3,000 years later, with much more sophisticated equipment, but we still have achieved little more. We're reinventing the wheel. We're still trapped in a pharmacological model. I think it's important to get out of that and become a natural scientist again. And I will stop simply by saying, I hope you understand me. I'll quote Flann O'Brien, who once said, your work is surely the handiwork of wisdom because not one word of it do I understand. And I will thank my collaborators, particularly the group of Peter Stenvigel at the Karolinska Institute, Rick Johnson in Denver, Barbara Natterson-Horowitz at UCLA, Peter Contango Renal Research Institute in New York, and of course, Joanna Piner-Gigler at the UVMS in Vienna. Thank you. I will take your questions.
Thank you so much for fascinating, really far-reaching talk. Just a reminder to put your questions in the Q&A, and I will read them out. I'll start with a question from Joel Mason. Do we yet understand the array of components in red meat that promote the pro-aging pathways? And why do poultry and fish meat not have the same effects? Is saturated fat too simple an answer?
Fabulous question, Joel. And there's no easy answer to this, but there are some things I would point out. Red meat, especially from domestic ruminants that we have not really evolved to eat. We've been eating them, at much greater frequency in the past couple 100 years than any other time in history, as opposed to eating game like venison. The basis there is that it's the phosphate. So calciprotein particles are, I suppose, a mix of a circulating inhibitor of vascular calcification made in our livers called phytoin A and calcium phosphate. So if too much phosphate in circulation is bound by calcium, phytoin A grabs that and you get a crystalline structure that we normally excrete in our urine. However, if the phosphate component is too great, then there's excess left over. It gets endocytosed. The calcium is released in endosomes, gets towards our mitochondria and causes dysfunction of cellular metabolism. Now, organic phosphate that we eat coming in through red meat is poorly regulated. But inorganic phosphate that's used in many modern preservatives is absorbed 50 to 100 times more readily. So we can become hyperphosphatemic without knowing it. If I recall rightly, a number of years ago, there was an American filmmaker called Moreland Spurlock tried a fast food diet. And this was one of the features of it, became hyperphosphatemic very quickly. Fish and chicken have less. And then I found out recently, fish also contain high levels of TMA, especially those that live deep within the ocean, because TMA is used by fish as an osmolyte to protect against organs against water pressure, essentially, when they deep dive. And therefore, not so good for us. So eating estuarine species may be better than eating, for example, cod or Atlantic salmon. I'm not sure of the story with chicken. All things in moderation, though I do still eat red meat from domestic ruminants.
Thank you. There are some more mechanistic questions waiting for you, but I'd like to ask you something perhaps more a little bit political or philosophical, and that is one of the clear messages that comes from your work is that to increase, maximize health span in human populations is, at least in part, a public health problem and requires public health solutions. At the same time, people like you and I go to geroscience meetings, and our geroscience colleagues are very much focused on molecular and pharmacological solutions. And part of your talk says that there are important solutions there too. Now, these are two communities, people working on public health and healthy aging, and
Yeah.
people who work on geroscience and aging. They don't talk to each other. So I'm interested in your thoughts about how to bring all of the stakeholders to the table, and what is the right answer? What if we get it right 10 years from now, what does that look like?
So it's an interesting one, especially in the face of many countries wanting to improve health span by 10 years by 2035. Very tall order indeed. I could be controversial here. I tend to bridge between the two worlds. And a lot of people that work on fundamental biological mechanisms do absolutely outstanding work. I've came from that community. But they don't grasp the complexity of jumping from a simple model organism to a human, and then to jump into the human exposome, and to jump into the transgenerational nature of the human exposome. We are, as I've mentioned in my talk, trapped within a pharmacological model where you have to have a target for a drug made by a company. The drug is then tested by clinicians who get the kudos, and then it moves into the healthcare system. 2 out of 3 drugs fail in phase 3 clinical trials. They're incredibly expensive. They don't always work. And the ones that do work tend to be derived from the natural world. You've only got to look at Ozempic and where it came from, or a lot of heart medication where they came from. So they are blindsided principally because what works in a laboratory will not always work in the real world. And we tend to be very precious about our own science and forget that the things that make us healthiest for longest, we have known about for almost 3,000 years. So we get a little vain about doing the science. And there is no magic bullet here, despite a lot of hype that says we can reverse aging. No, we can't. We can do it at a cell level, but not at the level of a person yet. We may be in the future. It's an aspiration for us all. And we do not need pharmacology to do this. I think the people that live longest and healthiest are social. They do things in moderation. They tend not to be overweight, and they tend to be spiritual. That doesn't really connect well with a lot of the molecular biology. And I think we underestimate biopsychosocial effects. And that for me is in doing bridging work has been an eye-opener coming to Glasgow and taking a top-down approach to understand the health disparity in the population and why people are showing signs of accelerated aging at such an early stage. there's multifactorial mechanisms behind this. There's not just one. And to have improvements in the next 10 years, public health is absolutely critical. You've only got to look currently at a declining life expectancy now across Europe, but particularly in the UK, because social systems are broken, healthcare systems are under stress, and public health measures are declining. All the gains that have been made in the previous 120 to 130 years are being eroded. And at least on the positive side, our technology may step in to help us. There are alarm bells ringing, and hopefully we'll wake up from this sleepwalk and do the simple things first. I think we need to move away from a system of sick care to one of true healthcare and go for preventative measures first. That's what I would go for and what we're aiming for, because if we're going to rely on pharmacology for this, it will take longer and there'll be a lot of misses. And therefore, we know what's successful already.
Thank you. We have a large number of questions coming in, so hopefully we can get through as many as possible. Let me start with a question from Shelley Fang. Is there a progressive increase in TMA during the progression of early stage CKD to ESKD? Do the cookie extract supplementation experiments that you mentioned also work in improving their gut microbiome?
So, Shelley, as the composition of the microbial community changes in the course of the disease, it gets progressively more dysbiotic, and you get more bugs that make pretty nasty inflammatory agents, including TMA. And what we do see with the short-term intervention using resistant starch or inulin is you get more saccharolytic bacteria. So we shift the whole composition of the community to one that is less, pathogenic. It's a small step to trying to have a more effective solution. But yeah, I would say you shift the whole community to one that is more health promoting, but you do not, make it normative again, which is unfortunate. But there are ways that we have thought about trying to improve that further, and that's an ongoing process. But I think potentially it's very hopeful given the preclinical data that other groups are now publishing.
Shandong Wong says, thank you for your talk. You mentioned that NRF2 is the master regulator of the aging process. Are there any reliable data in the literature that unequivocally prove that NRF2 activation actually leads to increase in lifespan in mammals? For example, any data on increased NRF2 activity in centenarians?
Interesting question, because I would say the data shows that if you knock out NRF2, you have decreased health span. It's not one for increasing lifespan, and we're not trying to advocate activating it to increase lifespan. We're advocating activating it to improve health span. And if you take a biomimetic approach to that, animals that live in extreme environments have, and there's a large literature database on this, some of which was being produced by myself and my colleagues, shows that those animals all have enhanced NRF2 activity to deal with stressful environments. Also, if you go to naked mole rats that really do buck the trend for life expectancy for a rodent, they have enhanced NRF2 activity. In human centenarians, they tend to have a lot of other features, but they have a more normative microbiome that has the capacity, I would say, to produce more NRF2 activators.
Thank you. From Chris Wiley, thank you for such a fascinating perspective. Can you comment on the consumption of iron in red meat and related sources, and whether this plays a role in degenerative pathology?
I would love to be able to, but I'm not sufficiently well informed on that. We've only started to read on ferroptosis. I can't give you, a clear steer on that. I would like to, but come back to me in a couple of months' time and I may have something to say.
And getting back to the environment, Saidas says Hippocrates was indeed ahead of his times. Your talk was interesting and very clear, but what is not is how to quantify the exposome and where to begin to intervene to maximize health span, especially as it's not easy, not as easy as quitting smoking or similar exposures or identifying something like smoking or similar exposures.
Yeah, I think it's a really good point. Um, so as I tried to allude to in my talk, we really need, extensively more exposomic data, and we need to learn how to integrate it. So that is one for the future. At the moment, I think at least what people like me are trying to do is to advocate for simple ways to make ourselves physiologically more robust until we understand the interplay between exposome factors and our own molecular and cellular biology. Hence the route to activating NRF2, because that is how the natural world engenders animals living in extreme environments with the capacity to adapt to exposome stress more effectively.
Susan Stewart asks, people who report feeling better than ever on a carnivore diet, could this be a short-term benefit that harms in the long run? And maybe cutting out things like processed carbs are part of that short-term feeling better?
Um, Difficult for me to gauge confidently being a molecular biologist and a nutritionist, but yes, if you're on a carnivorous diet, then long term, you're going to suffer renal problems. That's quite clear. So one also, though, has to factor in at what age you're undertaking such a diet. I do realize as you get older, you may need more protein in your diet. I personally like to eat red meat, but I eat game, I eat venison. I try to eat things that our ancestors ate that supported, a more normative human microbiome. I think also, I don't know if there's a placebo effect or not, but you may be quite right in that processed carbs are, yeah, we like them. Um, we're now living in an era biologically of food surplus, unlike our ancestors who would have struggled to get carbs off them. So yeah, it's a good point, and it's one I have to think about a little bit more.
Um, so I wanted to ask about how we balance an approach of focusing on nutrients from foods versus pharma, and you talked a little bit about this, and whether ultimately, if we're looking at particular foods that seem to be beneficial, might there be a specific ingredient which, if we could extract that and dose people pharmacologically, we have more control. And my own bias is actually towards healthy diet and not trying to find drugs. But many people think, if we go the drug route, then we can control everything much more accurately than with a diet where we don't know how much we're dosing.
Yeah, I think that's quite right. And again, it's back to having a sufficient depth of data to enable us to do that. I think personal exposomics are still some way off. And therefore, in light of that, altering the diet, taking key components of it is a safe and potentially very effective way of doing it. We're currently doing this using a range of different NRF2 activators. We're also looking at modulating one carbon metabolism through supplementation to counteract the mitochondrial dysfunction that occurs with age. That in laboratory studies works extremely well. But again, taking that out into the real world is another matter. And trying to do that so that it can be deployed widely and not just in the context of the developed world is not always easy. Um, so I think you're probably going to end up needing both approaches, and we're calling currently for the creation of exposome or environmental pharmacology as a field of study, because there will need to be, I think, a marriage of both things, but the quickest and most effective way currently is start with what we know best, which is food. and then become more sophisticated, because there is a pressing need to do this.
That's a great place to leave us today. I think an important message and a very thought-provoking talk. So thank you again,
Thank you
Professor
very
Shiels. I think I speak for everybody that this was really enjoyable seminar. So thank you for joining us
Thank you
today.
very much. Take care. Bye.